Hello, everyone. Today we are going to talk about the first topic of the second APPI course, APPI 2, about meteorology and aerology. In this topic, we are going to go a little deeper into these subjects. We will talk about the evolution of the day. We will talk a bit more about the types of clouds, and about what a stable atmosphere and an unstable atmosphere are. We start with the first topic, the evolution of the day. Here we have to divide it into two types of flight, dynamic flight and thermal flight. You can find more information about dynamic flight in this tab. If we fly in dynamic conditions, which means flying facing the sea using sea breeze, using only the wind, the evolution of the day will be as follows. In the mornings, we usually will not have wind. There will be zero wind or very light wind. Remember that in dynamic flight, we do not use thermals. So if there is no wind, there will be no soaring. If we do dynamic flights without wind, the flights are very short, and usually they are descent flights or instructional flights. This happens from sunrise until, let's say, 9 or 10 in the morning. I have to clarify that all these daily evolutions depend on the flying site. Every flying site is different. I am giving general guidelines, but they do not always apply. So a dynamic flight between 6 in the morning and 9 in the morning is practically a descent flight. Then as the day warms up, stronger wind may appear close to midday. Most likely we will have enough wind to be able to soar. This means we have more than 15 kilometers per hour. As the afternoon progresses and we approach 3 p.m., the wind in some dynamic sites can even become very strong. The wind can increase to 30 or 40 kilometers per hour. Obviously, in those conditions, we cannot fly. Regarding wind direction, during the day, the sea breeze comes from the sea toward the land. So if we have a slope facing the sea, it will usually be facing the wind. But as the afternoon goes on, this wind direction tends to change. What we colloquially say is that it starts to cross. In other words, it becomes more parallel to the shoreline, and therefore also parallel to the slopes and cliffs. Close to sunset, the wind tends to decrease a bit and tends to cross even more. And once it gets dark, the sea breeze reverses and the flow goes from land to sea. Therefore, the wind either crosses too much or becomes land to sea, in which case it is not possible to continue flying because we need wind hitting the slopes and rising. Now, if we fly in thermal or thermodynamic conditions, which you can see in more detail in this tab, things change a bit. Since we use both wind and thermals, in the early hours of the day, something similar happens. They are descent flights with very little activity. But even if it is still early, 9 a.m., 10 a.m., we may already find some activity, some thermals, even if there is no wind. If we approach midday, that would be, let's say, the peak time for thermals. Between midday and 3 p.m., we have the strongest thermals. It is usually the time when advanced pilots go flying. In some areas, the combination of wind and thermals is so strong that people do not fly close to 1 p.m., 2 p.m., or 3 p.m. because it becomes too extreme, too strong. In more moderate areas, those are the hours when pilots prefer to fly because they will find the strongest thermals. But in more extreme places, people stop flying at those hours. Something similar happens close to sunset. Both the wind and the thermals decrease. It also depends a lot on the flying site. Close to sunset, some novice pilots or even schools do their last flights because they find weather conditions that are suitable for learning, with little wind and almost no thermals. Very close to sunset, there are no more thermals, and what remains is a bit of wind. In some valley areas, you can find the restitution effect, which is a very gentle, calm lift in the center of the valley. At night there are no thermals, probably no wind, and besides that, night flying is prohibited for paragliding and free flight in many legislations. So at night, we do not fly. Regarding clouds, we have already seen in the previous course two types of clouds, cumulus and stratus. In the theory book, in the APPI flight log, at the end, in the last pages, you can find a chart with all types of clouds. This time we are going to review some more types. As I said, we have already seen cumulus clouds, which are the thermal clouds, and stratus clouds, which are like fog or moisture clouds. We also have a mixed type, which is stratocumulus. Usually there are no thermals under a stratocumulus. It was probably a cumulus that stopped being active, and now it is just a cloud drifting with the wind. It can be distinguished from a cumulus because a stratocumulus tends to be more horizontal than vertical, and you cannot see growth. It looks static, like a piece of cotton floating in the sky. It's more compact than a stratus, since a stratus is like a mass of fog. A stratocumulus has the shape of a cumulus, but does not have the activity of a cumulus. Then we have the most dangerous cloud for paragliding, which is the cumulonimbus. This cloud is a cumulus that has developed excessively in the vertical direction, so much that it produces precipitation. It is a storm cloud. Under a cumulonimbus, there can be rain, hail, lightning, and it is very dangerous for paragliding because a cumulonimbus generates a very powerful thermal or lift, a suction that can make us climb uncontrollably without being able to do anything about it. It can capture us, suck us in, and make us ascend to almost stratospheric altitudes, more than 10,000 meters. At those altitudes, life is not sustainable. One can die from freezing, from lightning, or from hypoxia. So we must always avoid getting close to or flying near a cumulonimbus. On the other hand, at high altitudes we have the whole family of cirrus clouds. They do not have any direct effect on our activity. They are clouds at about 10,000 meters of altitude, basically ice in the atmosphere. What could affect us are cirrostratus clouds, which create large areas of shade. Even though they do not have direct activity, that shade cools the ground, and therefore we get fewer thermals. Finally, we have the family of nimbus clouds, which are usually storm clouds that were once cumulonimbus, but have lost their strongest thermal activity, and are now large masses of moisture in the atmosphere that continue generating precipitation. Be careful, they can also be dangerous. Lightning can still strike under one of these clouds, and there could still be some remaining lift or suction that makes us climb uncontrollably. But they are not as powerful as a cumulonimbus. We must avoid them, yes, but they are not as critical as the one mentioned before. You will also find many combinations. Altocumulus, altostratus, which in practice are not very useful to distinguish. It is better to keep in mind these four big families: stratus, fog-type clouds; cirrus, very high clouds that do not affect us directly; cumulus, thermal clouds, the most important ones for free flight, the ones we look for; and nimbus, storm clouds. And the combination of cumulus and nimbus is the most dangerous cloud, the cumulonimbus. Now let's talk about the stability and instability of the atmosphere. These terms can be confusing because they are somewhat contradictory. We have a vertical axis, which will be altitude or height, and a horizontal axis, which will be atmospheric temperature. When we talk about an unstable atmosphere, it is, let's say, the atmosphere that paragliders hope to have. It is the ideal atmosphere. And what does that mean? That as we go up in altitude, the environmental temperature decreases. How do we graph this? If we have a given temperature at a certain altitude, as we go up in altitude, the atmospheric temperature decreases. That is an unstable atmosphere. Now, what is a stable atmosphere? It is when the temperature does not cool as we go up in altitude. How do we graph that? Simply like this. The temperature remains constant with altitude. Remember, on the x-axis, the horizontal axis, we have temperature, and on the y-axis, we have altitude. In a stable atmosphere, as we go up in altitude, the temperature remains constant. What is an extreme case of a stable atmosphere? When the temperature not only does not decrease, but actually increases with altitude. This has a specific name and can be drawn like this. We have a given temperature, and instead of decreasing as we go up, it increases. That is called a thermal inversion. Now the question is, which type of atmosphere is better for thermal paragliding? Stable, unstable, or thermal inversion? For a thermal to last a long time and reach great heights, the atmosphere has to cool with altitude. Because if the atmosphere does not cool, the thermal, which always cools as it rises, will quickly equalize its temperature with the surrounding air. In a stable atmosphere, the thermal will last less time. In an unstable atmosphere, the thermal will have more chances to gain altitude and reach great heights. That is why when we fly thermals, what we want is the atmosphere to be as unstable as possible. When there is a stable atmosphere, it is usually not good for flying. So much so that when we have this extreme stable atmosphere, the thermal inversion, flying conditions are very poor. They tend to be very turbulent, very gusty, and the thermal lasts very little. We do 1 or 2 360-degree turns, and that is it. The thermal is gone. The atmosphere does not always have the same characteristics. Normally it varies. For example, at low altitude we may have some inversion, then it may become stable, and then become unstable. That is one example, but the combinations can vary. It could be the opposite. It starts very good, very unstable, then becomes stable, and then there is a thermal inversion at higher altitudes. In some places, you can get weather forecasts that show these atmospheric characteristics and indicate whether we are going to have a good thermal day or good thermal days ahead. In other places, this information is not available. I have a video here where I talk in more detail about unstable atmosphere, stable atmosphere, and thermal inversion. Up to here, this video on meteorology theory, corresponding to APPI, course number 2. Do not forget to subscribe to my channel and give it a like if you enjoyed this video. Thank you very much for watching until here, and see you in the next video.